Hey, what's up guys, Tanmay here for our channel Simple Snippets. So this is the fourth video tutorial for a playlist Boolean Algebra and Logic Gates. Now this is the part 2 and in part 1 we discussed 5 different Boolean algebraic laws. So if you have missed them, you can check it out. In this video tutorial, we'll be discussing 4 different laws. The commutative law, associative law, distributive law and absorption law. So as you can see in the table in the previous video, we learned the first 5 different laws, that is identity law, idempotent law, dominance law, involution or double negation law and negation law. And in this video, we'll be discussing the laws from 6th to 9th. The 10th law, that is the De Morgan's theorem or De Morgan's law, we'll be discussing in a separate video starting from commutative law. Consider two variables a and b, and since these variables are Boolean algebraic variables, they'll be taking only two values, that is 0 and 1. So here's the expression 1, a or b is equal to b or a. And the expression 2 is a and b is equal to b and a. Well, the expression itself are self-explanatory, but let's see the truth table values. For the first expression, we have the 4 cases, wherein in the first 2 columns we have the a and b values, and the next 2 columns are the LHS and RHS respectively. As you can see, the values match, that is, the expression 1 is proved. Let's see the second truth table for the expression 2. Again here we have the first 2 columns as the input values a and b, and the next 2 columns as the LHS and RHS respectively. Also, as the LHS is equal to RHS in all 4 cases, we have proved the expression 2. So now let's move on to the next law. So the next law is associative law. As you can see, there are 3 variables in this law, a, b and c. So here the number of variables or the number of variations of input is equal to 2 raised to n, where n corresponds to the number of variables. By this I mean the number of possible input variations are to the power of 2 raised to n, where n is the number of variables. So in this case, n is 3, as we have 3 different variables. So the possible variations would be 2 raised to n, which is 2 raised to 3, which gives us the value 8. So as you can see in the table, we have 8 different rows created for these truth tables. Now let's start proving the first expression. This is our first expression. A or b or c is equal to a or b or c. So let's first start the input variable values. For the first variable a, I write 4 times 0, then 4 times 1. For the next variable b, I write 2 times 0, 2 times 1, again 2 times 0 and 2 times 1. For the last variable c, I write 0, 1, 0, 1 alternatively. And this covers all the possible variations of input values. Now let's calculate b or c. For the first case, we have b or c as 0 because b and c both are 0. Let's calculate a or b. Again, a or b is 0 as we have both the values of a or b 0. Now the LHS is this entire part. So it is made up of a and b or c together. That is this part and this part. We just need to take an OR of these two parts. So we need to take 0 or 0, which will again give us 0. For RHS, we have this part and this part, as you can see in the expression. So we need to take an OR between these two. So this 0 or C, which is again 0. So again we have 0. So here we have LHS equals to RHS. Similarly, we have to calculate for all these other 7 cases. So I'll just quickly calculate by applying the basic Boolean algebraic operations, that is OR and AND operations. In this case, we'll be using only OR operations. B or C for case 2 is 1, A or B is 0, so LHS would be 1 and RHS would also be 1. So I'll just fill out these values and in the end we'll cross check whether LHS is equal to RHS. Okay, so I'm done completing this table. So as you can see, if you compare the LHS and RHS columns, all the values are equal to each other. That is, in all cases they are equal to one another, so proving that this expression is correct. So we just proved one expression. Let's go ahead and prove with other expression. Now again, first I'll fill up the variable values. So I'll just repeat again. For the value a, I write 4 times 0, then 4 times 1. For variable value b, I write 2 times 0, 2 times 1 and repeat that. And for variable c, I write 0, 1 alternatively. Now in the LHS, we have a part b dot c or b and c. So I separately calculate that in this column. For the RHS, we have a component A and B separately. So I calculate that again in this column. And then in the end, we again calculate LHS and RHS. So let me just quickly calculate these values. Okay, so I have calculated the values, and as you can see, the LHS is always equal to RHS in all cases, hence proving this expression. Now if you don't know the logical AND operation or logical OR operation, you can check out the previous videos where we have discussed these basic operations. So let's move on to the next law. Okay, so the next law is distributive law. As you can see, we have three different variables A, B and C. So the number of input values will be 2 raised to 3, which is equals to 8. So as you can see in the truth tables, I have written the values of A, B and C as follows. So let's have a look at the equation 1. So we have this as LHS and this as the RHS, and we need to prove that these two are equal. So in the LHS part, we have an individual value A and we have a combination of B and C. So I calculate B and C first, and to calculate B and C, we need to take a logical AND operation between variable B and C. So let's take a logical AND operation between them. Okay, so now we have calculated B and C. So to calculate the LHS completely, we need to take an OR operation between this entire component and this A. So we need to take a logical OR operation between this column and this column. So the result will be as LHS over here. So let me just calculate the LHS. Now if you don't know how to calculate logical AND or logical OR operations, just take a look at the previous videos in this playlist, because we'll be needing them throughout these lectures. Okay, so now we have got the LHS. Now let's take a look at the RHS. We have the component A or B, and we have one more component A or C. So I have calculated them separately. So let me just calculate its values. Okay, so I have calculated the individual components of the RHS, that is these two components. So now to calculate the entire RHS, we just need to take a logical AND operation between these two values. So let me just take the AND operation. Okay, so now that we have calculated both LHS and RHS, we just need to compare these two columns. Now as you can see, the values in LHS are equal to RHS. Hence we have proved that this equation is true. So now let's move on with the next equation. In the next equation, we have LHS as A and this entire component B or C. So I calculate B or C separately first. So let me just calculate the OR operation between B and C. Now to calculate the LHS, we just need to take a logical AND operation between operator A or variable A and this entire component. So calculating the AND operation to get the LHS in this column. Okay, so I have calculated the LHS now. Let's have a look at the RHS. In the RHS, we have two components A and B and A and C. So I have written them separately in these two columns. So let me just calculate these separately. So as you can see, we have calculated the separate components A dot B and A dot C. So we just need to take a logical OR operation to get the entire LHS. So I'll just calculate the entire RHS. Okay, so here are the values of RHS. Now comparing LHS and RHS, we can see that for each case LHS is equal to RHS. Hence this equation is proved. So now let's move ahead to the next law. Okay, so the next law is known as the absorption law. Since there are only two variables involved in these laws, okay, cut that. Since there are only two variables involved in this law, the number of input variables or the number of input values would be 2 raised to 2, which is equal to 4. So let me just write down the input values. So I have now written down the input values for both the equations. So let's have a look at equation 1. In equation 1, we have two components. We have an individual variable A and we have a component A or B. So I calculate A or B separately first. So I'll just calculate the values. Now to get the LHS, we just have to take a logical AND operation between A and this component. So calculating the LHS. Okay, so now we have calculated the LHS. Now for the RHS, we just have the value of variable A. Now we have already written down the value of A, as you can see in this column. So I just need to repeat it again in RHS. I'll write it down as it is. comparing LHS and RHS, you can see that for each value in LHS, we have an equivalent value in RHS. Hence this equation is proved. So let's move on to the next equation. In the next equation, we have a separate value A and a component A and B together. So let me just first calculate A and B in this column. Now for the LHS, we need to take a logical OR operation between the variable A and this entire component. That is, we need to take a logical OR operation between this column and this column. So calculating that, we get okay, so I have calculated the LHS. Now for the RHS, we simply have the value of variable A. So I'll just write down as it is. And comparing the LHS and RHS, we can see that LHS is equal to RHS. So this equation is also proved. So that's it for this video, guys. So in this video, we learned the 4 different Boolean algebraic laws. Now in the next video, we'll learn the De Morgan's law. If you like this video, give it a thumbs up and share it with your friends. Also make sure to subscribe to this channel so that you get notified when we upload the next videos. Peace.